Okay, that is another example. We did a similar one yesterday, I guess. So okay. In 1990, John deposited $5,000 in a mutual trust fund, which promises an interest of 7.5% compounded yearly. The amount that Y dollars at the end of n years is this. Again, you're familiar with this, right? It's a compound interest. The rate is here. So we are just using here A equals P times 1 plus R to the power n. This is time, R. So that is 0.075 at 1. So here we have 1.075 to the power n. Okay? Okay, even if it is not given, you should know that actually we should use this formula. Okay, question A. The amount of money John will have in 1998. That means after 8 years, right? So how much will he have at the end of this 1998? Here we have deposits, that is $5,000, right? Times 1.075 to the power n. And what is n? It is 8. So this thing is equal to, it is 5,000 times 1.075 to the power 8, which is equal to 8917.39. Let's say corrected 2 decimal places. Okay. So John will have $8,917.39 in 1998. B, find the year in which the amount of money first reached $20,000. Okay, now here, this thing is, what is it? Amount is given. So first, we need to evaluate T, time. And after that, we can add it to 1990, and we'll find the year where the amount of money first reached $20,000. So using that thing, that A is equal to P times 1.075 to the power T. Actually, we have P plus R. We're expecting that. That means that when our money grows to $20,000, right? So here we have $20,000 equals our P, our investment is $5,000 times, and here we have 1.075 to the power T, right? And from here, 1.075 to the power T equals $20,000 over $5,000. Just simplify this, what we have here, 20 over 5, that's equal to 4. So here we have 1.075 to the power T equals 4. As I say here, also this is another example that involves logarithm. And without using logarithm, we cannot solve this problem. Maybe another problem we can draw, it is graphical method, but algebraically we cannot solve this problem. The only way is we have to use logarithm. So using the definition of logarithm, what is T here? That T is equal to logarithm of 4 to the base 1.075, and which is approximately equal to, here we have logarithm, and the base we have 1.075, and here we have 4, which is equal to 19.16, let's say 87, and blah, 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 corrected 4 decimal places, right? Actually, it takes more than 19 years, right? When it is 19 years, it will be a bit less than 20,000, right? So that means that since we are evaluating this, our interest at the end of each year, right? So we need to count in years. It is 19 years, so 20 years, and 21 years. So the answer here will be, what is it? Dots, 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 20 years. That means it is 20. So 1990 plus 20, that is the year. Find the year in which the amount of money first reached 20,000. Which year is it? Year 2010. Because it takes 20 years for this money to grow to $20,000. Okay? You can just evaluate here, for example, if n equals t equals 19, evaluate this, it will be less than 20. When it is 20 years, it's about a bit more than 20. So anyway, it will reach after 20 years. That is in 2010. All right. Give your answers correct as 3 significant figures. Solve the following equations. Okay, we have a lot of questions here. We can just solve maybe 2 of them. Which one? Let's start with D. Okay, let me solve here D. It is about, the exponential equations, right? 2 times e to the power 2x plus 1 equals e to the power x plus 1 plus 15e. And we know that this e is just a constant number, approximately equal to 2.71. Okay, that's a constant number. Some students, they just confuse. It's a kind of variable. It's not a variable. It's a constant number. It's a special number. That's why we use a special letter for this. So now we know that I can just rearrange and write it as 2 times e to the power x. Here we have squared times, this thing is e to the power 1 minus e to the power x times e minus 15 times e, that's equal to 0. Right? Take everything to the right hand side. Now let's say t is equal to e to the power x. Now we are using auxiliary variable to solve this equation, right? If you just rewrite this, what we have here? Here we have 2e, 2 times e. Here I have t squared minus, here we have e times t, because it's a constant, we need to write this in front of the variable, minus 15e is equal to 0. As you see, here is a common factor. It is a constant number, so I can just divide both sides by e. What we get here then? 2t squared minus t minus 15, that's equal to 0. Right? It's a quadratic equation. And first try actually factorization method. Does it work or not? 2t, it is 15, it is, we can write it as 5 times 3, right? It works, I think. So this 2t squared minus t minus 15 is equal to 0. And this thing is, what is it? 2t times t. This thing is 5 times 3. It is minus, so let's put minus here. Cross multiply. 2t times t, 2t squared, 5 times negative 3, it is negative 15. So I can factorize it as 2t plus 5 times t minus 3, that's equal to 0. From the first factor, we get this solution, t equals negative 5 over 2. From the second factor, we get this solution, t equals 3. As you see here, t is e to the power x. E is a positive number, right? And whatever x is always, what is it? Positive number. So this t cannot be equal to negative number. And that's why this answer is rejected. So the solution of the given equation. Oh, we didn't find it. Okay, t equals 3. Now from here, what is t? T equals e to the power x. E to the power x. Okay. So let me change my pencil color so you can see this much better. Now from here, what is x? X equals, because it is e, right? Natural logarithm of 3. And the question states that write your answers, correct as 3 significant figures. So I have to evaluate and write the answer. X equals, here we have natural logarithm of 3, and that's equal to 1.0986 1 blah blah blah. It continues. Since it says 3 significant figures, right? Starting from the first non-zero digit, here we have 1, 2, 3, right? So since this digit is greater than 4, I have to add 1 to the previous digits. So I'm just going to omit this thing. If you add 1 to 9, what we have here? We have 10. So the answer is 1.10. Okay, guys, once again, you should be careful in the exam. If you write, for example, 1.10, if you just write 1.1, it will be wrong because it's asking correct as 3 significant figures. Okay, so I need to write here 3 digits. Okay. Three more examples. Given that we are given a kind of exponential function, it's a function because here we have exponent. It says that, okay, y is equal to a times x to the power b plus 7. The first piece of information here, it says that y equals 79 when x equals 2. So y equals 79 when x equals 2. So here we have a times 2 to the power b plus 7, right? I can immediately simplify this. That means that a times 2 to the power b equals, take this 7 to the left-hand side, 79 minus 7 is 72. How about the second piece of information? What gives us here? It says that y equals 16 when x equals 4. So this y is 16 when x equals 4. That is a times 4 to the power b plus 7, right? Now again, if you just simplify this, here we have a times 4 to the power b is equal to 16 minus 7 is 9. Okay, so we have to solve this simultaneous equation. They are not simultaneous linear equations, simultaneous exponential equations, right? So either, what is it? We can use graphical methods or substitution method or elimination method. So here, if I just divide side by side, divide the second equation or first equation by the second equation, what we have here? A times 2 to the power b over a times 4 to the power b equals, on the right hand side, 72 over 9. So this a is common factor, they cancel each other. What we have here? 2 to the power b minus, this one is 2 to the power 2b. It is 2b, right? It is divided. 72 over 9, it is 8. 8 is 2 to the power 3. So from here, b minus 2b is minus b. So what is minus b? Equals 3. So b equals negative 3. Okay. Now we need to find the value of a. So I need to substitute either here or here, doesn't matter. You can get the value of a. So that is, here we have a times 2 to the power minus 3 equals 72. Right? So what is a? A equals 72 over 2 to the power minus 3, or 72 times 2 to the power 3. And that is 8 times 72. What is 8 times 72? That's equal to 576. Okay. So dots, the solution of this equation, or the answer to this question, is a equals 576 and b is equal to negative 3. Okay. Another example. We have 2 examples. That would be enough, I think. And I will stop teaching. Okay. Here, let's solve question A. Solve the simultaneous equations. So the first one is 2 to the power x minus 5 to the power y is equal to 3. And the second equation is this. That is 2 to the power x minus 3 is equal to 21 minus 5 to the power y minus 2. Right? How can we solve this? Here we have 2 to the power x. Good, good. So also again, we will use that elimination method. Right? So let me just rewrite this. Here we have 2 to the power x minus 5 to the power y equals 3. And this thing, I can write it as 2 to the power minus 3 times 2 to the power x plus, take it to the left hand side, 5 to the power minus 2 times 5 to the power y. On the right hand side, we have 21. Right? So actually, I need to eliminate either that axis, right, or x or y. Let me just eliminate, for example, y. To eliminate y, let me multiply here both sides by 25. So here we have 2 to the power x minus 5 to the power y equals 3. Here I'm multiplying both sides by 5 squared, that is 25, right? What I have here? Here I have 2 to the power minus 3, 5 squared, 2 to the power x, plus 5 to squared times 5 to the power negative 2. I mean, that's equal to 1. So here we have only 5 to the power y. How about on the right hand side? Here we have 21 times 25. Actually, that's also 25. Now, if you just add side by side, here we have minus 5 to the power y plus 5 to the power y, right? They cancel out each other. What we have here? Here we have 2 to the power minus 3. Here we have 5 squared. Here we have 2 to the power x plus 2 to the power x, right? We are just adding. The things are gone. Equals 3 plus 21 times 25. We can simplify this, but now I'm going to evaluate a bit later. So this 2 to the power x is a common factor. Take this out. 2 to the power x, right? And what is this thing? That is just 25 over 8, right? 25 over 8. Plus, what do we have here? 1. And on the right-hand side, we have 21 times 25 and plus 3. That's equal to 528. Okay. Now, if you're using calculator, I can just write it as 2 to the power x equals 5 to 8 over 25 over 8 plus 1, which is equal to, so here we have 5 to 8 over fraction 25 over 8 plus 1. That is equal to 128, right? That means 2 to the power x equals 2 to the power 7. So x equals 7. Good. Now I can get a value of y. We change our marker color here. Let's say this is step 1, and here we have step 2. Substitute here. If you substitute here, 2 to the power 7 minus 5 to the power y equals 3. Or 5 to the power y, right? Take to the right hand side, 3 to the left hand side. This thing is 128 minus 3, which is equal to 125. From here, we can get that we know that 125 is 5 cubed. So here we have y is equal to 3. So the answer to this question is x equals 7 and y is equal to 3. That is the solution of this equation. Okay. All right, gentlemen, I'm gonna stop sharing. Okay, and also stop recording. That's all for us. That's the last exam class.